Hello students. So my channel Clear Your Doubt is going to help you with your preparation journey. If you are a JEE mains or advanced student or NEET-UG student, you can get help from me with your doubts, with your questions, especially PYQs, previous year question papers, and to clear the concept and previous year questions, they guide you with the real syllabus that you have to cover. So, if you are a JEE mains or advanced student, you can get help for mathematics and physics. And if you are a NEET-UG student, you can get help for physics only. Okay, so till now I have helped with 50 questions to my students in a very little time, and I plan to do so in further in future also. Okay, so let's start this question. This is very good question, especially for JEE advanced students. So let's just do this. This question is from rotational mechanics, and it is based upon angular impulse, right? So whatever you do in linear mechanics, you have to do the similar thing in rotational motion, right? Let's read the question first. Two uniform identical smooth rod AB and CD. Okay, so figure is given to you. So these are the, this is B point, right? AB and CD, two smooth rods are there. They can rotate in horizontal plane. So underline this word in your mind, that horizontal plane. There's no vertical motion, so there won't be any weight acting on it. Okay, so about fixed vertical axis passing through A and C. दो वर्टिकल एक्सिस हैं ए और सी पे, अबाउट विच दे आर हिंज्ड, ठीक है, या फिक्स्ड यू कैन से. End B of rod AB collides at midpoint of rod CD. So let's just see. This is the end B of rod AB collides with the middle point of CD. ये CD है and this is the middle point of CD. यहाँ collide होता है, ठीक है. Before collision, angular speed of AB, let's call it omega AB initial, is equal to 4 radian per second, and in anti-clockwise direction. Omega AB final after collision, what is the omega? It is 1 radian per second. So here kinetic energy is being dissipated in some other form of energy, right? CD is at rest. Okay, initially CD is at rest. So before collision CD is at rest. So omega CD initial would be 0. If angular speed of AB after collision is 1 radian per second anticlockwise, let's just focus on one thing. So direction of rotation of AB is not changing. It is anticlockwise earlier, and after collision as well it is anticlockwise. Angular speed of CD after collision will be. So omega CD final you have to find out. First of all, tell me one thing, just pause the video and think why there won't be an angular momentum conservation equation. That means you cannot apply angular momentum conservation. Why? Just pause the video and think about it. Okay, so I'll tell you why. So in AB and CD, they are two different systems. AB is rotating with omega, certain omega, and CD is at rest. AB is colliding with CD. So torque, or you can say momentum applied by AB, angular momentum applied by AB on CD would be external to it. So the torque applied by AB on CD would be external for the CD, and in any system if there is presence of external torque, you cannot apply conservation of angular momentum. Alright, then what? Although you can just see here rod AB and CD is given smooth, but still there can be energy dissipation in any other format as well. So you rule out the energy conservation equation as well. So what is left? So you are left with the impulse equation. So as I tell you, impulse in linear motion is J is equal to delta P, right? Change in momentum. And similarly, angular impulse. angular impulse is the moment of impulse into r is equal to delta p. So I'm trying to write magnitude. These are not vector. In vector this would be r cross j. So don't mind me writing j cross r. This is not cross rather than multiplication. Okay. And this won't be delta p. Rather this would be I omega, change in angular momentum. And how do we write angular momentum? We write it with L, right? Delta L. So let's just think about it. So rod AB is going to apply a angular momentum on CD, and CD is, and that will have two components. One is this component shown here, other is going to be like this or in other direction. So tell me one thing, this moment of this momentum can only be taken from vertical component of that momentum. So this vertical component I have assumed as j. So for rod cd, what do I what do we see? So let's take the moment of momentum. So j into L by 2. Okay, so length of the rod, both of the rod I'm going to consider L, and mass I'm going to consider M for both of them. Why? Because they both the rods are identical as given in the question. So J into L by 2 is equal to I omega, change in angular momentum. I is the moment of inertia, and omega final minus omega initial, and omega final of what? CD, and omega initial for CD is 0. Okay, so from here what do you get? J into L by 2 is equal to I. I is ml square by 3. Let me write little clearly so that you won't have problem. So ml square by 3. So moment of inertia is going to be from at one end. You cannot take from the center of mass because rod is rotating about this fixed point. So ml square by 3 into omega f. So omega final, let me call it omega, just for the simplicity in writing. So let's call it equation 1. Now for rod AB, let's take the angular moment of momentum. So tell me one thing, this is J, right? So from, if AB is applying momentum on CD, same momentum is going to be applicable in that direction in AB, right? Just opposite. Newton's third law, you can imagine rate of change of momentum is force. Similarly, so action reaction kind of thing. Now tell me one thing, which component of J, which component of this J is going to give you the moment of momentum? So this component is going to give 0, right? It is passing through the line of action, right? So there is no, so it's perpendicular component. So this component, and what is this component? J cos theta, right? By the way, in this question I haven't mentioned it. So theta is given as 53 degree. Okay, so don't worry, in your examination you will be given the value of cosine or sine of that angle. It won't be 53. You don't have to remember the value of cosine 53 or sine 53. Now let's calculate moment of momentum. So moment of momentum would be for rod AB, j cos theta into L, right? By the way, here L by 2 was due to because it was acting at the midpoint. So half of the rod length was assumed. Sorry, I forgot to tell you back then. Is equal to change in momentum. So I into omega initial minus omega final. I'm considering change, so don't worry about the sign, right? So we are talking in terms of magnitude, so sign doesn't really matter. And cos 53 into L. I here again ml square by 3 into 4 minus 1, right? So let's just let's assume 2 equation 2. Let's divide equation 2 by equation 1. Equation 2 upon equation 1. I'm just writing it, right? So you may not, okay. Cos 53 upon 1 by 2. This you would get on the left hand side. On the right hand side, what will you get? Omega by 3. Alright. So what would be omega? Okay. So omega would be J into L by 2. Did I make any mistake? Oh, this would be 3 by omega. I'm sorry. So we are dividing second equation by first. So this would be 3 by omega. I sensed something was wrong at least. So this would be 3 by omega. We are dividing second equation upon first equation. So omega would be 3 by 2 upon cos 53. So cos 53 is zero point 0.6. So 1.5 upon zero point 0.6. So this is 15 upon 6. So this is 6 to the 12 and plus 3 6.5. 2.5 radian per second. Okay. So which option is correct? First option. So thank you so much for watching the video. I will prioritize your PYQ questions over other your assignment question. So that means मैं PYQ question पहले बताऊंगा rather than assignment question, right? Please subscribe to my channel for this amazing, such amazing questions. आपका concept clear होगा through these kind of questions. They are really good questions, and do subscribe to my channel. Have a great learning. All the best. Thank you.